Dear students, today I am going to discuss fifth module, Digital Signal Processing. Title of the module is Design of FIR Filter, and here today we will discuss the Introduction to Frequency Sampling Method. Frequency Sampling Method. The design procedure for FIR filter using frequency sampling method. Generally, the FIR filter will be specified by the given filter impulse response coefficients, that is h of n. So the DFT coefficients of h of k will be given by h of n equal to 1 by n summation k equal to 0 to n minus 1 h of k e power j 2 pi kn divided by n. H of k, capital, this is frequency response, this is impulse response. H of k, this H of k will be summation n equal to 0 to n minus 1 h of n e power minus j 2 pi kn divided by n. Okay, so this H of k is nothing but a DFT samples, and this, what is the relationship between this H of k and H of z is this z is equal to this z, here this z is equal to e power j 2 pi kn, that is the relation k value. Here this k relation between h of k and h of z, e power j 2 pi kn divided by capital N, that is the relation. Okay, so h of z, so directly we can write this formula, h of z equal to summation n equal to 0 to n minus 1 h of z is at power minus n. So this h of n, we know the formula that they are substituted here. So finally, if z is equal to e power j omega, then this k value, we are going to replace like this, z equal to e power j omega, then h of e power j omega equal to z. So we know that omega k equal to 2 pi k divided by n, where omega k is nothing but your frequency sampling or sampling frequency. Now, how to design FIR filter using frequency sampling method. Here we are going to use only type 1 design, that's why I mentioned here. Draw the filter graph of whatever they given in the given question, that is as given in the FIR design using window function. Next, draw the unit circle and the mark points k is equal to, because always the z transform will be represented inside the unit circle. I told all the this one h of z will have both a coefficients and b coefficients, b coefficients, a coefficients. Here we are discussing about FIR filter. You will have only a b coefficients, the a coefficients will be is equal to 1. All the b coefficients should be located inside the unit circle, then only we can say it is a stable. And so now they are telling draw the unit circle and mark the points from k equal to 0 to n minus 1, that is for 360 degree. So if k is equal to 1, suppose if k is equal to 1, then theta 1 will be is equal to 360 divided by n. Next, you need to find the h of k value, and the k will be replaced by replace omega divided by 2 pi k divided by n. So this is the desired frequency response. From that we know this is your omega c. What is omega c? Omega c is your digital cutoff frequency. Omega c is your digital cutoff frequency. Okay, so this value will be exist from this is the graphical representation for this desired frequency response is hd of omega equal to this is the value. What is the value? E power minus j omega, and this will be exist from 0 to omega c, and this is your omega frequency axis. And or we can write it as h of k equal to e power minus j n minus 1 into pi k divided by n. For k is equal to 0, pass band value. For 0, that is the stop band value. This is stop band, this is the pass band. Okay, this is pass band, this is stop band. That's why they represented k equal to 0. Okay, this will be pass band. K is equal to is not equal to 0 means then it is a stop band. In second type, this omega will be, this is the first type only I am showing here. In second type, this omega will be represented by 2 pi by n, k plus 1 by 2. In first type, this omega will be represented by 2 pi k divided by n. But in the second type, this omega will be replaced by 2 pi divided by n, capital N into k plus 1 by 2. Okay, and now fourth step, coming to the fourth step, if n is equal to odd, here we are going to take two conditions. If n is equal to odd, okay, we are going to use to find the impulse response. Okay, to find the impulse response, if n is equal to odd, to find the impulse response, we are going to use um, h of n is equal to, this is very very important, n sometimes they may give 7, sometimes they may give 9, and sometimes they may give 8. Okay, so if they give even number, means you have to use this formula. If they give odd number, for that here h of 0 value will be is equal to 1. Okay, for if n is equal to odd, the h of value will be is equal to 1. So now coming to this odd and even, for this finding h of n, h of n equal to 1 by capital N h of 0 plus summation k equal to 0 to n minus 1 divided by 2, 2 into re of h of k e power j 2 pi k n divided by. Actually here we are going to neglect the imaginary part. Okay, we are going to neglect the imaginary part. We are going to take only the real part. This should be very very important, and you have to make sure that the data after finding this h of, to finding this h of n, you have to take only the real part. You should not take the imaginary part. Okay, same thing, if n is equal, and also this h of 0 will be is equal to 1. This is the condition. And now if n equal to even, then h of n equal to 1 by n h of 0 plus summation k equal to 1 to n by 2 minus 1. Here it is n minus 1 divided by 2. You see the difference here, it is n minus 1 divided by 2. Here it is n by 2 minus 1. Here also we have to take a real part. Okay, 2 into re h of k e power j 2 pi k n divided by n. Okay, so now we got the h of n value. After finding the h of value, you need to find the h of z. We know the formula. Okay, h of z is equal to, what is h of z? H of z is the system function or transfer function. H of z is the system function or transfer function. The system function can be obtained by summation n equal to 0 to n minus 1 h of n z power minus n. This is the system function or transfer function. Okay, so the system function or transfer function is the final thing here we are going to find. So here in frequency sampling method, we are having 5 steps to follow the procedure. Okay, so here first step is from the given filter graph, you need to design the FIR filter using window function. The second step is you have to draw the unit circle and you have to mark all the k values. Okay, draw the unit circle and you have to mark all the k values. And here you will have only b coefficients. Your a coefficients will be is equal to 1. The next one, here we are going to use 2 steps. In type 1 design, here we are going to discuss only type 1 design. Type 2 design is not there in your syllabus. In type 1 design, the omega will be replaced by 2 pi by k. Okay, and in type 2 design, the omega value will be replaced by 2 pi by n k plus n by 2. And the next one, to find the h of n, you have to split the n equal to even and n equal to odd and n equal to even. N equal to odd means you have to understand that here your this value this n minus 1 divided by 2. For n is equal to odd, here it is k equal to summation k equal to a 1 to n minus 1 divided by 2. At the same time, for n is equal to even, here it is n by 2 minus 1. These two difference you should be very much careful. Then after that, after finding the h of n value, you need to find the h of z. So z transform of h of n is h of z. Okay, z transform of h of n is equal to h of z. Okay, so this is about your design procedure for your frequency sampling method. The next we will do the problem using frequency sampling method. Thank you.